Now that we have completed the design for the slab, we proceed to the next question, asking you to sketch the details of the reinforcement for the slab in the section AA. Referring to the key plan, the slab that you are designing is this. This is the section AA. Imagine you are cutting a section here and view from the side how the reinforcement bar should look like. Dealing with the detailings of the slab, these are the informations that you need to incorporate. First, you will need to get the grid line correct. Refers to the key plan. For section AA, your grid line it will be 1 to 2, and the span of the slab is 5.6 meter. That gives you grid line 1 to 2 with the span of 5.6 meter. You need to look at the positions of the grid line as well as the beam. The beam here seems to be having the grid line at the center. Therefore, the grid line should fall at the center of the beam. Next, you look at the adjacent edges. There is no adjacent slab here, and there is a void here. That means if you are cutting the section here, the slab it will be in the single span. Your cut section here should be without any adjacent slab here. That gives you the grid line number 1 to 2. The grid line appears at the mid of the beams. There are beams at both sides without any adjacent slabs. So your slab sections will look something like this. The span of the slab is 5.6 meters. Next, you need to provide the slab names. We are referring to the slab BC12. Normally, we name the slab names by the x-axis first, followed by the y-axis. That gives you slab BC12. Indicate the thickness. From the key plan, the thickness is 150 mm. Make it clear with the names of the slab. Next, we deal with the reinforcement bar. There are main reinforcement and secondary reinforcement. The main reinforcement will be put at the bottom layer in order to have a higher effective depth. As for the secondary reinforcement, they are put on top of the main reinforcement bar in the transverse directions. Now, if you look at the arrangement of the reinforcement bar here, you know that this will be the main reinforcement and this will be the secondary reinforcement. This is as far as the bottom reinforcement bar is concerned. Now the next question here is how the reinforcement should be arranged. Is it in this manner or in this manner? Which layer of reinforcement should be put at the bottom? To determine this, you will need to first refer to the structural key plan. Know which directions is the shorter span. This is the shorter span as compared to this. You know that the slab is more critical in the shorter span. The deflections is likely to occur at the shorter span. That means when this is the shorter span, the bending of the slab it will be more critical in these directions. The directions of bending will indicate the existence of the bending moment. In order to resist the bending, you will need to have the reinforcement bar longitudinal to the bending. That means the main reinforcement, it will be in these directions, which is the shorter span. As for the secondary reinforcement, it will be on these directions, in the transverse directions. Because of this, the main reinforcement, it will be the bottom layer of rebar, followed by the secondary reinforcement. Now, if you cut the section here, you view it from this side, you will see this reinforcement at the bottom and this reinforcement on the top. That gives you this reinforcement at the bottom and this reinforcement on the top. Instead of giving the reinforcement arrangement in this manner, which is wrong, the reinforcement should be given in this manner. Now your next question. Under what circumstances the reinforcement will look something like this? This happens when you are doing the cut section here. Since the questions asking about section AA here, then you will see the bottom layers here and the top layers here. When you view from this side, that's why you will see the longitudinal rebar at the bottom. If you cut the section here, you view from the other side, then the condition reversed. It will end up to be something like this. This leads to an understanding that sketching the reinforcement bar in the slab, you have to pay attention on the arrangements of the reinforcement bar. Know which layer of reinforcement bar should be at the bottom and which should be on top of the bottom reinforcement bar. Once you have decided how the reinforcement bar should be arranged, next it will be to level the reinforcement. Based on the calculations, H10 350 is provided. Then you will level the reinforcement H10 350. In our previous examples, you are only asked to design the longitudinal reinforcement, assuming the secondary reinforcement will be the same as the longitudinal reinforcement. Then you should clearly indicate the bar size and the spacing for the secondary reinforcement. If the main and the secondary reinforcement are of the same size and spacing, you can group them together. If the size and the spacings varies, then you're going to level them separately. For example, level the main reinforcement and then level the secondary reinforcement. This is for the bottom reinforcements. How about top reinforcement? Although in our analysis, when we talk about this span, this is discontinuous edge and this is also discontinuous edge. In the analysis, we assume it as simply supported slab. However, you know that it is actually monolithically cast with the beams. Even though there are no moment analyzed at the support, it is always a good practice for you to provide the reinforcement bar at the support, just in case there are any negative moment. Since the amount of reinforcement bar provided here is not large, you can simply adopt it here. The same amount of reinforcement. Therefore, that gives you H10 350 for the top reinforcement at the support. Regarding the arrangement of the reinforcement, you know that the main reinforcement, it will be in these directions. When you determine the effective depth, we are referring from the top surface of the slab to the centroid of the reinforcement. When you do the calculations for the negative moment at the support, the effective depth reversed. Now we are talking about the soffit of the slab to the centroid of the reinforcement. If you have decided which side is the main reinforcement, then both the top reinforcement and the bottom reinforcement should comply with it. That gives you a total symmetrical arrangements between the bottom reinforcement bar and the top reinforcement bar. When your bottom reinforcement bar is arranged in this manner, your top reinforcement bar should be arranged in this manner. Now, if your bottom reinforcement bar is arranged in this manner, your top reinforcement bar should be arranged in this manner. It is basically symmetrical at the center of the slab. Now, when you provide the top reinforcement here, you cannot simply indicate it's stopping somewhere without giving any dimension. Under such circumstances, the contractor do not have any idea where to stop this reinforcement and where to stop the reinforcement here. Now the question here is, how do you determine this distance? If you refer to the typical industrial practice, normally they will put a note stating that where slab sections is not provided in the structural drawing, the following rebar curtailment details shall be adopted. Except waterproofing areas and MME room, no curtailment should be applied. The meaning of the curtailment here is indicating to you that you can reduce the amount of reinforcement bar here. In the case that you are dealing with waterproofing area and MME room, you will need both layers of reinforcement bar to be fully stretched over the entire slab. Now coming back to the questions, what is the dimensions that shall be appropriately provided here? This you may refer to the end span here, where the length here, it will be about 20% of this span. In another word, you may take this distance equals to 20% of this 5.6 meter. Based on the calculations, 20% of this 5.6 meter is equals to 1,120. Remember that when we provide detailing, if possible, we provide in the intervals of 25 mm. As the workers on site, they are working on the basis of the inches and feet. A 25 mm shall be equals to 1 inch. This is allowed them for easy conversions between the SI unit and the imperial units. With that, you can choose to have 1,125 mm, or you can choose to provide slightly more. You can round up to 1,150 or 1.2 meter, so that it is easier to remember. Maybe I just stick with 1,150, which is good enough for me. Now in the case that you are dealing with the internal span, the required anchorage length here and here shall be in accordance to this. Normally we will put this as symmetrical. Whatever length that you provide on this side, you will arrange it the same for the other side. Same goes to this. Now the question here is, how much is this width? To determine the length here, you need to first get 3 numbers. We are talking about 1/3 of this span, which is 0.33 times the length of the span, and then 1/3 of this span, which is 0.33 L2, and also 50 times the diameter size. Based on the 3 values obtained, you use the largest value. Sometimes this span and this span are not identical. Therefore, it is wise for you to compute all 3 values before you decide. Whatever values that you obtain as the x, remember to round out to the interval of 25 mm. Next, if you are dealing with this part, same principles apply. Get 3 values, 1/3 of this span, another 1/3 for this span, and then 50 times the bar diameter. You choose the bigger value. So this is about the detailings of these slabs, and this gives you some understandings how you should provide the detailing for the slab. If you wish to test your understanding, you can challenge yourself. Based on the details as given here, try to sketch the cut section here. Probably take this as a BB section. See how it should look like. Follow through the process of providing the essential informations, which you will see that providing the grid line from B to C, where there will be continuous edge. The beam fall at the centers of the grid line. This beam also fall at the center of the grid line. There are adjacent slabs. Now the longitudinal rebar here, it will be at the bottom layer, and this rebar, it will be at the top layer. And then you provide the reinforcement and the support here. Also provide reinforcement and the support here. Same goes to this side, but you cannot see that. And the span of the reinforcement, it will be based on the curtailment. We are referring to something like this: 1/3 of the adjacent span, 1/3 of your span, and at least 50 times the bar diameter. Since your reinforcement bar is 10 mm diameter, 50 times the bar diameters, that means at least 500 mm. From simple calculations, this span is shorter. 1/3 of 2000 is about 667. As for this span, 1/3 of 4000 equals to 1333. Round to the nearest 25 mm or 50 mm. That gives you your x equals to 1, 3, 5, and 0. That will be the anchorage length required for the top reinforcement. If you cannot imagine that, you can imagine your sections will be something like this. This will be the B and C. You have adjacent slab. The arrangements of the reinforcement bar, it will be something like this. There will be top reinforcement bar, and this length, it will be 1350. Same here, and 1350.